Welcome to part two of our discussion on utility and looking at the framework for how consumers make choices. We're still going to be using consumer utility. Now what we're going to do is construct a model of a two-product world where consumers are making choices between the products based on budget constraint. And really, what this is what's called constrained optimization, right? As a consumer, you'd like really an infinite amount of the products you like, right? You want more vacation time, money to spend on vacations, perhaps a bigger television, perhaps a bigger house, perhaps better clothes, perhaps tastier food or healthier food or better car, better whatever, right? There's all of these things you may want more of, but you have a limited budget. So the decision each consumer faces is how to spend money on all of these things that you'd like based on a limited budget. The way we're going to be constructing this is with indifference curve analysis. It takes the preferences of the consumers, looks at the budget. You can get an idea of what should the consumer purchase. What we'll be doing in this is a two-product world, right? And we went through this idea of the two-product world and explained the rationale for it with the production possibilities frontier in the last section. Everything we do with this, while it's only a two-product world, and we assume you have to spend all your money on this, it all would extend to a world with more than two products. Why do we use two products? We can graph two products really easily. If you get into upper-level economics, you can do multiple products really easily with calculus, right? This is constrained optimization for those who've done a lot of calculus. You'd be using Lagrangian multipliers is the term. If you haven't had calculus, you could ignore that last part. We don't use calculus in this class, of course. We just do this with graphing, and intuitively, I think you'll be able to get this. This is, it's a little bit different, but it's all graphical for this class. So we use a two-product world. Ideas do extend the trade-offs a consumer faces between two choices. Now, before we get to the consumer preferences, we're going to look at the budget line. The way we go through this is we're going to do an example. So we're going to consider a person has $40. And in this two-product world for our individual, the two products they consider are Blu-ray discs or hamburger meat, right? Those are the only two products in this world. The person has $40, and we assume the person has to spend it all, right? Once again, if you wanted to extend this where you had three products where one was savings, you could do it. You then just have to start to rely on calculus, right? Or multiple periods gets a little trickier. So that's two products, Blu-ray discs or hamburger meat. So you have $40. Price of a Blu-ray disc is $10. The price for a pound of hamburger meat is $5. Well, we have enough information to graph, right? We have plenty of information right now to graph this. I'm assuming you haven't graphed this yet, unless you've looked ahead in the textbook and gone ahead and tried this before you watched the lecture. If you did, that's great. Either way, what I'd like you to do is pause this now, take a moment, and try to graph this on your own. Note though, what I want on the X and the Y axis is Blu-ray discs and hamburger meat. I want nothing to do with money. We're looking at how many Blu-ray discs or how much hamburger meat could you purchase and try to graph the budget line before we attack it together. So go ahead and take a moment, pause it now. Okay, I hope you paused, took a chance, tried this on your own. We're now going to do this together. So graphing this, put out the graph. What we'll do is we put one of these products on the x-axis, one on the y-axis, and it really doesn't even matter. I'm going to put hamburger meat will go on the x-axis, and Blu-ray discs will go on the y-axis. So the first question we need to figure out here is how many Blu-ray discs or how much hamburger meat could this consumer buy? The easiest way that I think you can find this out is to look at what happens if you spend all your money on one or the other, right? So you have an income that equals $40. Okay? If you want to spend all of your money on Blu-ray discs, you just take the income divided by the price of the Blu-ray disc. Well, in this case, it would be $40 divided by 10. If the consumer wanted, he or she could buy 4 Blu-ray discs and no hamburger meat. Right? Simple division. You have $40, the Blu-ray discs, $10. If you want to spend all your money on Blu-ray discs, you could buy 4 of them. For hamburger meat, the equation would be you take the income divided by the price of hamburger meat. Well, that's 40 divided by 5. Means we could buy 8 pounds of hamburger meat. Let's label these 1, 2, 3, 4. And on the x-axis, we go through 8. You buy 8 pounds of hamburger meat at $5 each if you buy no Blu-rays. Well, this is a line, so you know you could just connect the points. And this is going to be your budget line. And we label that with BL for budget line. Notice the other points on the budget line should all fit within our income. Well, let's just look here. 2 Blu-ray discs, 4 pounds of hamburger meat. That's on the budget line. Does that make sense? 2 Blu-ray discs, $10 each is $20 of our $40 in the budget. We have 20 left for hamburger meat, which means we should be able to buy 4 pounds at $5 a pound. This does seem to match up. 3 Blu-ray discs at $10 matches up with 2 pounds of hamburger meat at $5, right? Everywhere on this budget line, you're spending all $40 on Blu-ray discs or hamburger meat. Okay. On the screen, you just see it in equation format, right? $10 times the Blu-ray discs plus $5 times the hamburger meat. So $40. The graph that we just put on, it shows the maximum of the 2 products the consumer could purchase. I'm thinking this graph should seem somewhat similar, right, to the PPF. Yeah, I mean, it doesn't translate perfectly, but if you're spending all your $40, right, we're not judging right now yet. We will be judging soon. What the right purchase is. We really know, though, if you spend all your money, you could really have any bundle on there. If you're inside the line, you're not spending all your budget. If you're outside, you don't have enough money to spend that much to buy those products. So inside, on the budget line, you're spending all your money. Inside the budget line, you're not spending all of your money. Beyond the budget line, you can't, right? You don't have the money to make the purchase of those products. Okay, what happens when the budget line changes? There's 2 ways the budget line could change. You could have an increase in income or a decrease in income in terms of a pure shift. The other way you can have a change, we'll talk about in a moment, is when price changes. When the income changes, we make this, we're kind of have the assumption, unless we're told otherwise of ceteris paribus, that all else is held equal. Which means the prices for the products are the same, so the slope of the line is the same. So when the income changes, what happens to the budget line? It will shift outward or inward, right? More choices or fewer choices. Okay, we have a generic budget line, right? No values indicated. If you get an increase in income, what you just see is a parallel shift of your budget line that is outward, right? You could buy more of product X or more of product Y when you have more income. If you have lower income, the budget line would shift inward, showing the budget line with a decrease in income. Buy fewer of product X or product Y. Relatively straightforward. The one thing to note that we did mention before, the slope of the line is the same, right? We assume the prices of X and Y, unless you're told they change, it's assumed to stay the same. We just see an increase or decrease in the budget line. Okay, what happens now if price changes, right? There's two ways the budget line could change. You could have an income change or the prices could change. Well, let's draw in our initial budget line. What happens if the price changes, right? And we're going to be looking only at one price at a time in our models. You can model multiple prices at a time. That's a little bit beyond what we're going to handle in the principles level. So let's say product X is the one changing. Right? Product X is the one that's changing. And what happens if the price of product X decreases? Well, the budget line is going to what we call rotate. If the price of product X decreases, first, if you buy only product Y, nothing changes. Right? If the price of product X changes, but the price of product Y stays exactly the same, nothing happens. If we go back to the Blu-ray and hamburger meat example, if the price of hamburger meat goes up, but you only buy Blu-rays in the first place, you're still going to be able to buy 4 Blu-rays. So you start at the same point on the y-axis, but if the price of product X decreases, that means you can buy more of product X for every amount of product Y that you purchase. So the budget line, when the price of X drops, the budget line rotates, and it rotates outward. Right? This is one thing that until you really start to think and let this set in sometimes is a little bit confusing. The price of X falling means the budget line rotates outward. Right? Now intuitively that should make a lot of sense. If the price for the hamburger meat dropped, you can buy more hamburger meat, which means the budget line goes outward. But the price falls while the budget line moves outward. If the price for product X decreases, if the price for product X increases, you'll have fewer opportunities with your budget, so the budget line would shift inward. So here's our budget line where the price of X goes up. Right? It rotates inward. If you only cared about product Y, doesn't matter because you're just going to buy product Y. But if you buy any product X, your opportunities would decrease because price of X has gone up. For every amount of product Y you buy, you can now have fewer units of product X. Okay, we've now talked about the budget. We're going to shift gears, move away from the budget, and talk to what do consumers prefer, right? We know how now to graph how much money they have, which tells us how many of each product they could buy, and also what happens if the amount of money they have changes. Thankfully for this, we just need to know how consumers rank preferences, right? We're not looking for them in this way to assess, I say this is worth 30, right? We just need to know how a consumer prefers one combination of a product versus another, one combination of products. So much of product X and so much of product Y versus a different level of the bundles. So an indifference curve, it's a line that connects all of the combinations of the commodities that are equally desirable to the consumer. And think about 2 different products that you like. Maybe it is, maybe you like spending money on clothes and you also like, you also like going to amusement parks, right? That's two products you can spend your money on. You might think that 8 new pieces of clothing and 4 trips to the amusement park would make you just as happy as 5 pieces of clothing and 10 trips to the amusement park. Right? I mean, those 2 bundles, you're giving up. In one of them, you get more clothing, fewer amusement park visits. The other, you get more amusement park visits, but fewer clothing. If you thought those 2 combinations were equally attractive, they would be on your indifference curve or unindifference curve for you. Those are 2 combinations that are equally desirable to you. But there are probably other combinations of clothing and amusement parks that are also equally desirable to you. So what the indifference curve captures is every combination of a bundle that's equally desirable to the consumer. And we call it an indifference curve because you are indifferent between them. You don't care, right? You'd be just as happy with any of those combinations of products. What we're going to do is just take a moment, put up a what we call a general or a generic indifference curve. Okay, this is a figure out of the book, the quantity of pizza and the quantity of Pepsi. Right, and this actually shows two different indifference curves for our consumer. One indifference curve is a little bit lower than the other. And notice on the points A, B, and C, those are all on the same indifference curve. Well, what does that mean? That means the consumer is equally happy between any of those 3 points. Right? The consumer would be just as happy with the small amount of Pepsi and the larger amount of pizza as the very large amount of Pepsi and a small amount of pizza, or something in the middle. But then we have another curve out farther. What can we say about that curve out farther? Well, you get more. Look at D. You get more of both pizza and Pepsi. There's something, there's the idea of non-satiation of preferences, which is a fancy way of just saying more is better. Right? As long as these products aren't bads for you, you don't like, as long as you always want more of the product, point D is 100% superior to point A. What that also means is every point on indifference curve 2 is preferable to every point on indifference curve 1. So here you have two different indifference curves. Indifference curve 2 is clearly preferred by the consumer to indifference curve 1 because more is better. This figure shows a situation that we cannot ever have occurring, which is that intersecting indifference curves. The indifference curves for a consumer can never cross. Take a moment and try to think logically why that's the case, focusing on bundles A, B, and C. I want you to pause it and try to write out a sentence or two why it's impossible, and then when you resume, we'll explain. Okay. Why is this impossible? Well, we have one indifference curve that has points A and B and continues on this way. Another that has A and C. Well, if we look at points A and C, C, you have more of both pizza and Pepsi, right? So point C is clearly better than point A. So you are happier with point C than point A. However, since these indifference curves cross, the logic tells us that point B is just the same as point A, and point C is just the same as point B. Well, if A, you're just as happy with A or B, or C or B, that means you must be just as happy as A or B. Can't happen, right? So it is impossible for us to see indifference curves intersect. You will always see them more, when you see what's called an indifference map, it will always look like this. You can have more than these. You'll have more than two on an indifference map, right? You'll have several. Indifference curves will keep going outward and outward because more is better.